Good morning, everyone. This is Yagnapriya from Cse G section from Srinivas Ramanujan Institute of Technology. Today, I am here now to discuss about the topic bipolar junction transistor. Let's go through it. Bipolar junction transistor. Bipolar junction transistor introduction. The bipolar junction transistor (BJTs), a cornerstone of modern electronics, is called as cornerstone of modern electronics, was invented in 1948 or 1947 by William Shockley, building upon the work of Jan Bardeen and Walter Brattain, who developed the point contact transistor in 1947. Here's more detailed look at the history. 1947 point contact transistor. John Bardeen and Walter Brattain, working at Bell Labs, invented the first working transistor, a point contact transistor. The first transistor was invented, which is named as a point contact transistor. Next, in 1948, bipolar junction transistor was invented by William Shockley at Bell Labs. William Shockley, also at Bell Labs, conceived of the improved junction transistor, which became the BJT. Early 1950s production and widespread use. The BJT entered production in the early 1950s and led to the first widespread use of transistors. 1956. In 1956, the three got the Nobel Prize. Shockley, Brattain, and Bardeen were awarded the Nobel Prize in Physics for their invention of the transistors. Decline and CMOS dominance. While the BJT was the device of choice for decades, its use has declined in favor of CMOS technology in the design of digital integrated circuits. So, bipolar junction transistors are semiconductor devices used for amplification and switching. They consist of three layers of semiconductor material forming two p-n junction. Next, BZTs can be classified into two types, NPN and PNP. Based on the arrangement of the semiconductor materials, they are classified into two types, NPN, PNP. The structure of BZTs. A bipolar junction transistor BZT is a three-terminal semiconductor device with three doped semiconductor regions. What are the emitter base collector? Separated by two PN junctions, forming either an NPN or PNP. So the basic structure is in the basic structure we have three terminals, two types. Three terminals means we know that base emitter collector. Two types means NPN, PNP. Here the diagram what I given is here the emitter collector base. This is NPN BZT. This is the PNP BZT. In NPN consists of two n-type regions. What are the emitter collector and the base is p-type region. Here we go in PNP, it have one n-type base and remaining two are the emitter collector or belongs to the n-type region. The small difference between them is the direction of the what's that IB. The direction of the IB is different. It's the one it is in opposite and it is in same direction. Next one, two PN junctions. The BZT structure creates two PN junctions, emitter base junction. And next one, collector base junction. Operating principle of BZTs. So a BZT controlling a larger current between the collector and emitter terminals with a small current flowing between the base emitter, acting as the current amplifier or switch. Structure, types. Structure is BZT consists of three layers of emitter base collector. Types A, NPN, PNP. What is the operation means? It operates in three ways. Forward bias, reverse bias, current flow. The base emitter junction is forward biased and allowing current to flow from emitter to the base. Reverse bias. The base collector junction is reverse biased, creating a large depletion region. Current flow. A small current flowing from the base to the emitter controls a much larger current flowing from the collector to the emitter. In amplification, switching, operator regions like active region, saturation region, cutoff region, it works on. So, current voltage characteristics. The current voltage characteristics of a BJT, particularly in a common emitter configuration, reveal distinct operational regions like cutoff, active, and saturation, where the collector current is controlled by the base emitter voltage and a collector emitter voltage. So first one, cutoff region. In this region, the base emitter voltage VB is low, typically less than 0.6 volts. And the base collector junction is reverse bias. The collector current is very small, essentially zero. And the transistor acts like an open switch. In active region, the base emitter junction is forward biased. VB is greater than 0.6 volts. And the base collector junction is reverse biased. Next, in saturation region, both the base emitter and the base collector junctions are forward biased. In active region, the collector current is controlled by the base current and the collector emitter voltage. In saturation region, the transistor acts like a closed switch. Biasing BZTs. Proper biasing is essential to operate a BZT in active region for amplification. Common biasing techniques include fixed bias, emitter bias, and voltage divider bias. Each method has advantages and disadvantages that affect stability and performance. Next one, BJT junction transistor biasing involves applying DC voltages to the base emitter collector terminals to establish a desired operating point, it means Q point, for proper transistor function, ensuring the transistor operates in the active region for the amplification or switching. Why is biasing is necessary? Establishing operating points, maintaining active region, optimizing preferences like performances. It means establishing operating point means biasing sets the transistor's DC operating conditions, which is crucial for proper AC signal amplification or switching. It means operating conditions means Q-cent point or Q point. We call it as Q-cent point or Q point. Next, maintaining active region. Biasing ensures that the transistor remains in the active region where it can amplify or switch signals effectively. Next one, optimizing performances. Uh, Current biasing allows the transistor to operate efficiently and produce a stable, undistorted output signal. How is biasing achieved? By DC voltages, forward and reverse biasing, biasing circuits, resistors. Common biasing configuration means base bias, it means fixed bias. Emitter bias means self bias. Voltage divider bias. Okay, these are the biasing BJTs. So next one, applications of BJTs. BJTs are widely used in amplifiers such as audio amplifiers, switches, and in various electronic circuits, including those for audio amplification, radio amplification, and digital logic. So amplification means audio amplifiers, radio frequency, RF amplifiers, high gain. In switching, electronic switches, digital logic circuits, saturation region. Other applications like temperature sensor, converters, oscillators, detection circuits, demodulation and modulators. In BZT is widely used in amplification circuits such as radio amplifiers and radio frequency amplifiers. Their versatility makes them integral in various electronic devices and systems. Advantages and disadvantages. One advantage of BZTs is their high current gain, which allows for effective amplification, and however they can be less efficient than other transistor types such as field effect transistors. Understanding these pros and consequences helps engineers select the appropriate transistor for specific applications. Next one. So conclusion, bipolar junction transistors are fundamental components in modern electronics. Their ability to amplify switch signals makes them versatile and widely used. Continued advancements in BZT technology will enhance their performance and applications in future designs. Feel free to customize any of the slides as